various curves. But here, we will start the process from the beginning. Let me try with the first problem number A, which is 2x squared minus 3 over x squared plus y squared plus 1. Before you try, remember my words, before you try various passes, just try to substitute. You may find the value. So if I try to substitute in this guy, it's going to be 0 minus 3, 0 and 0 plus 1. So the limit for this one already exists and it's equal to negative 3. Just by making the substitution. Limit of an x and y tends to 0. This is going to be 0. This is going to be 0. That's going to be 0. So the limit is going to equal to negative 3, as you can see. So the limit exists and it's equal to negative 3. I didn't have to go through various passes or something. This function is continuous at the origin, and the limit exists and it's equal to negative 3. Okay, let's do problem number B. For problem number B, once you start substituting, you will end up having 0 over 0. Here the problem starts. Here we need to discuss our debate. So I will start. I will start with the first and simplest curve, which is at x equal to 0, which means the y-axis. All I have to do is to substitute. So it's going to be x equal to 0, y over 6 over y over 6 will be 1. So the kernel function is equal to 1. So taking the limit will lead that the limit of this guy is equal to 1. So that's the limit while you are working with the y-axis. Let's do exactly the same, but with the x-axis, where all the y values are equal to 0. Once you start substituting in your kernel with y equal to 0, the value will be 0. The value will be 0. 0 divided by x squared for any value of x. So, which means that the limit when y tends to 0 is equal to 0, as you can see. The two limits are not equal to each other. So from the beginning, you don't need to go Cauchy or something or to discuss the existence of this limit. Simply the limit doesn't exist. Okay? Because it has different values through different passes. So it depends on the pass, the value of the limit. So this is these are not equal, so the limit doesn't exist. For this problem, also it's really very nice problem. You have xy tends to the origin of an x squared plus y squared for a sine of a 1 over root x squared plus y squared. Okay, let's discuss this by going through changing or skipping the various parts, and I will go through the Cauchy by itself just for a trial, just moving x squared plus y squared equal to r. And in this manner, I will end up having r squared sine 1 over r. And here we go. This is r squared sine 1 over r. That's the kernel that we are going to discuss. Please concentrate with me. I'm trying to find a bound for this guy. I'm trying to find an hour bound for this guy. Okay, let's see. While r tends to 0, this is going to be, or when r tends to 0, and as you can see, we are going to 0, we will have 1 over 0, which is infinity. The sign of an infinity. Any one of you know what the sign, or the value of the sign, or the maximum value of the sign at infinity? Do you know?
Probably 1.
Yeah, probably 1. So what we mean is that the sign of 1 over r, absolute, this value will be for sure less than or equal to what?
1.
To 1. So once you have this fraction and multiply it by r squared, you will end up having r squared actually less than or equal r squared. So mainly we will have this guy, which is r squared. It's gonna be less than, as I told you, less than r squared. So I'm sorry, x squared plus y squared is gonna be less than or equal just to only r squared. And that's the fact that we will depend on. So the value of the function, which is x squared plus y squared, probably will be less than or equal to r squared, because the maximum that can hit is 1. So once more, we have considered this guy, which is root x squared y squared less than delta. Since x squared y squared less than r squared, so it's less than delta square, so all I have to do is to choose delta square by epsilon, and here the problem is proved, the theory is proved. Here is once more the definition as I told you. So squaring, you will have epsilon, and epsilon equal to delta square, so which means that the limit exists and it is equal to 0, as you can see. So this also can work for this problem beautifully. If I want to go further, I've now solved like 4 problems. Okay, I want to go to check the continuity. The continuity on certain function, it will have 2 parts. The function is defined. The function is defined, and also the limit exists. So we need the limits. We need the limits. The right and the left. This is going to happen in the 1 dimension. Okay, but here we are multi-variable functions. So we will need our study in the limits to be applied here once more on the general part for this problem. So once more, here we have f of x, y. If we are studying the continuity at the origin, we know the value of the function, because once x equal to y, the value is going to be 0. Remaining just to study the limit or in the neighborhood of the origin, which means when x doesn't equal to 1. This is what's going to happen at the time being. So along different paths, y equal to x, and if we use y equal to x as trying one of the curves, you will end up having 2x squared plus 2 over x squared, which leads that the limit is equal to 1. I believe if you just try y equal minus x, it's going to equal to negative of x, negative 1, sorry, which means that the limit doesn't exist. Yes, exactly right. Once you try at y equal negative x, the limit doesn't exist, which means although the function is defined at the origin, but the limit in the neighborhood of this point is not equal to each other, which means that doesn't exist, the limit, and the function is not defined, although it is defined, it's not continuous, I'm sorry, although it is defined at this point. Once more, let's see this problem. Another problem in a similar manner. It is defined at the origin, which is equal to 0. Now we need to study the case for this function, okay, of approaching the value of this function, but in the neighborhood of x doesn't equal to y. So once more, I will start through x equal to y in the kernel of this limit, which is limit x and y tends to 0 of x squared, y squared, blah, blah, blah. So just making x minus y, putting x equal to y, will force x minus y into a 0 level. So you will end up having x power 4 over x power 4 equal to 1. So if we want to do x equal to 0, for example, you will have the value of this function without any effort equal to 0. And once more, the 2 limits doesn't equal to each other, which means the limit doesn't exist, although the function is defined. So bottom line, the function is not defined at this point. We will continue more problems on continuity in our discussion in the next lecture as an introduction of the differentiability, because one of the conditions of the differentiability that the limit or the function should be continuous at the points inside U domain. Thank you very much for watching, and thank you for trying this. I know it's not that easy, but it will need a lot of work. It will need you at least to resolve these problems once more, to be just aware how we find the bound, how to bound your results. This is very, very important, especially that the coming days will be off, but the good thing that I believe our exam will be delayed a little bit. So study hard and to try to solve using your head. Thank you very much. See you next time.
تدرس السكوير؟
No, no.
ستوب؟
Just a second.
عشان بس ما نحرقش انا عمري ما عملتها تقريبا